All right. Hello, everybody. I am live streaming my homework to give me a little bit of pressure so that I don't spend too much time on it. I've been doing this machine learning class this semester. This is the final exercise. They've typically taken me roughly a day, which is probably too much. I think I'm going to try and do this in 1 hour. That will be my goal. I think I have enough knowledge and experience also now to be able to do this in an hour. But let's see. So, and I'm happy to hear any tips if somebody's watching and has some ideas. Feel free to put them in the chat. I can see that in front of me. And I'm going to be talking a little bit through my thinking. That helps me anyway. Maybe it helps somebody else if you're working on something similar. So this exercise is about doing very simple neural network prediction we're using scikit-learn in Python. And yeah, I think that's it. I haven't really looked at this exercise yet. So we're gonna read it together and then I'm gonna go do it. So so this data set for this is the PennWorld table data set. I've worked with this on some previous exercises as well. It's a data set of various like macroeconomic statistics for many different countries over a long period of time. And I think I'm not going to look at that now. I think I'm okay with that. So we can continue. The goal for this exercise is to predict the national real GDP, which is labeled RGDP NA, or the national TFP, RTFP NA. So that would be total factor productivity. Of each country based on other attributes and the values from previous years. Oh yeah, so this, I forgot about this. So this is a time series prediction problem. So this is what makes this tricky because we haven't done that yet. So I'm going to try and figure out how to do time series prediction using a neural network. I'm going to try and use a time series neural network, although I don't think that's required for this problem. But I think that would be much easier. I'm not really afraid of that. I might use ChatGPT. That's perfectly allowed for these exercises as well to help at some point. But I think we're gonna try and start without it and see how far we get. ChatGPT. Sometimes I feel like that's why I've taken so long on the exercises because it just suggests really dumb things and then I go in the wrong direction. Okay, so the data must be prepared for the time series prior to being used to train the model. We're using a neural network. We're selecting the target variable, selecting the input features, preparing the input features for the neural network, adding data from the previous years, create the model, optimize the hyperparameters, evaluate the final model, and save the final model. And there is a link here to the scikit-learn documentation for neural networks generally, I guess. This may not be specific to time series. So we're gonna see. We're gonna do neural network regression. Yes. So so far we've used this neural network, the multi-layer perceptron, to do classification, but this now is a regression problem. So there's kind of two new things. It's doing a regression and then also it's a time series. It's kind of tricky. Let's see where I get with that. I don't think I need to look at any of this in too much detail. Although I am going to go and read a little bit about time series. Let's see if we find anything. Okay, welcome to Para. Okay. We talk about what previous time series data is. Yeah, that's fine. I know what that is. There are probably better ways of doing that. Yeah, I guess as much. We're going to use scikit-learn, which isn't always the best, but it's what we know. We've been using it all semester. Okay, so our data is not time series like this with individual days. I think it's yearly data. It goes over the course of many years. I think 70 years in some cases. Though not all countries have that many years. And then there's 100 and more than 100 countries. So that's fine. I think our data is. Well, yeah, we need to set the date to be the index. Okay, that's no problem. We're going to set a goal. And we're going to split it into training and testing set. Oh, okay, yeah, so that's nice. So I didn't think about this. Normally when you do machine learning, you're going to have a testing data, and you can just sort of randomly take bits of data to test with. But of course, when you have a time series, you want to predict the future. So we're going to take the last year or several years potentially to be the testing data. And we may need validation data as well if we're going to be doing hyperparameter tuning. So we'll have to see about that. Performance measure, okay. RMSE, helper functions. Okay, yeah, so there's a regression results function that she's defining. That's fine. Feature engineering, yes, that's what we call hyperparameter tuning. Wait, is it? Oh, that's about deciding what goes in as input. Okay, that's a good point. Now, we want to predict GDP. Which will be based definitely on population and nominal GDP, inflation, things like that. Just a sec, I have someone at the door. Okay, and I'm back. Yes, okay. So yeah, we'll probably have to decide a little bit what kind of data. So I'm gonna maybe I'll take some notes in here. Just to think this through a little bit. Actually, I'm gonna take the notes directly in here. So we're gonna add some text. So testing data, end of time series, okay. Feature selection. So I'm going to look at the data in a second to do that. Okay. Defining training and testing set. Yes, that is fine. Cross-validation. Right, that's a question I have. So maybe tempted to gravitate towards the all-time favorite k-fold. Unfortunately, that would not be correct. The reason being it does not take into account the time series as it has some natural ordering. Yeah, so okay, that wouldn't work. I guess this much. Forward chaining. In forward chaining, say with 3 folds, the train and validation would look like fold 1, training 1, validation 2, fold 2, train 1 and 2, validation 3, fold 3, training 1, 2, and 3, and validation on 4. where 1, 2, and 3, and 4 represent the year. This way, successive training sets are supersets of those that come before them. Yeah, I mean, that makes sense. Okay, so oh, there's even a model for this a framework. So okay, that makes it nice and easy. Cross validation using okay, good. Spot check. What's that? Wait, this is not neural network. I think she's doing. What is she doing? Confused now. K and N and RF. Which, okay, it could be a neural network. Let's see. So, grid search. Yeah, that's fine. So, random forest. Okay, that's not what we want to use. Okay, that really doesn't help. Oh. Oh my god. Do I have a Medium account? Yeah, probably. Why is everything paywalled nowadays? Oh, come on. Oh, that sucks. Okay. Well, we might use ChatGPT to do this then at some point. Let me just Google one more thing. So, scikit-learn MLP regressor time series. That is not scikit-learn, but okay. Wait. Oh, it just restructures data for scikit-learn. That's great. Okay. This class mainly reshapes data so that it can be fed into scikit-learn's MLP regressor. Okay, that's perfect. So since that's the one we're supposed to be using, the MLP regressor. I think. Yeah. Yeah, perfect. Okay. So we're going to be using this. TS-learn. So model is the MLP regressor. From scikit-learn. And data preparation is going to be done by this one. Okay. Oops, what did I just do? Why did that move? Okay. Okay. Equal size time series, what does that mean? Does that mean all of the units need to have the same number of years? That would suck, because I don't think my data is like that. Okay. We'll have to try it. We'll see. There's not that much documentation here. This may be proved to be a little bit difficult to use. Okay. Actually, there's tons of documentation. Yeah, this is great. Yeah, this is great. There's so I'm not sure if I need to be using a pipe line. I mean, probably should, but I guess I just try doing the regression first, and then I can make a pipeline out of it afterwards. It's probably not that hard to do it like that. Okay, so maybe I just get started and see how far I get. So yes, we're going to actually gonna move this down. Yeah, I guess I'm gonna look at some previous projects. Gonna copy some code over because I've done a lot of this before. Let's see, I think the last one with this data was 8. Is that here? Well, yeah, I'm gonna need definitely this for my files. That's also where the data is. That's this one. That's this Penworld dataset. Okay. So what else do we need? What did I do here? I appended the exercise 8 path to the system so that I could do some. I don't know exactly. I guess I'm not doing it anymore. But there was something in here where I was running something from. Oh yeah, it was a. Oh yeah. Okay, that's this. So I made my own. This is something I wrote myself, a pre-processing step, and that is saved there. I might just check what is in there and see if I want to reuse that as well. So. Yeah. So that's an exercise 8. Pre-process. Yes. I'm dropping missing values. I'm dropping metadata.
It's 12 hours.
Right, I'm dropping. I'm creating a new column that is, or no, I'm just counting how many missing values there are in each column, and then I'm dropping the ones that have more than 2,500 missing values. I don't remember exactly what that was, but okay. Then I have the label columns, I have the value columns, and then I sorted it by country and year. That's what the kind of panel data setup. What do I do here? GF value columns. Oh, I'm interpolating between. So for the ones that are still missing, I'm interpolating between the missing values, and then I'm dropping the now the rows that have less than 25 columns with data in them. Yeah, I think all of this pre-processing is something I probably should reuse. Yeah, I don't think I need metadata. I think this is all a good way to approach this. So let me add this code here, and then we'll be doing that as well. So I do that at the top here. I will need pandas, pathlib, and joblib. And we'll leave those ones for now. We're going to import these ones. Actually don't know exactly where this is from. Should say it's somewhere here. Yeah, so it's this. Okay. And this one, of course. And then this one. So. Okay. I don't know why that works. That should have, I think, a backslash at the end, because the group name, it doesn't. How did this work? The course path also doesn't. Oh, it's because of the path library. Okay, yeah, of course. fixes shit like that. So, okay. We've got our data, we've got some things. So, oh yeah, pre-processing, we're going to run that. So that's this step. Okay. And then, yeah, I think the other stuff is not really relevant right now. I need to look at how to do this preparation now. So, I think that makes sense for me to structure it like that. Let's actually go directly to the regressor and see. Okay, so there's actually a lot of different support vector regression, and why is the other one not showing up? We want the MLP regressor. Okay. So let me just print this data frame here and see what we have. Okay. Need to install that first. See if that works. What did that? Oh yeah. Need to set up the paths first. Okay. Actually, don't need this, and I think I'm just going to delete it because it's cluttering my code here. If it doesn't work, then it doesn't work anyway. So, okay. And I think I just comment this out for now because it's just gonna just keep saying this requirement's already satisfied when I keep rerunning it. The preprocessing worked, I think. Yeah, we have deleted some things. I don't know if that was smart. We might try and not delete so many things, but I think it's okay. Yeah, so let's see. So we have the year column and the country code column. how does this work then? You, what's the X is NTS ZCD, whatever that is. So I guess that's what they explained in here somewhere. So max SZ is the maximum size of the time series in the set. Right, so I'm quite confused. So this time series is presumably just a series of data points 1242, 1342, or is that already? Yeah, no, that's this. So there's 4 points in time, 1, 2, 3, 4, and no, hold on. That's just the shape of it. Sorry. A time series is nothing more than a two-dimensional numpy array. Two-dimensional. Well, this is two-dimensional, so. But what we want is something that's three-dimensional, right? I'm kind of confused. I guess what they mean is like for each year, there'll be a two-dimensional array with the year for each country. I mean, there'll be a two-dimensional array with, like, let's say the years along the side and then all the data along the top. And in this case, there's only one data series, which is fine. That'll be like RGDP, and this is like for one country. So we would have several time series for one for each country, with potentially multiple, so two-dimensional data. That's how I understand it. So we manipulate sets of time series, yes. We can cast them into three-dimensional arrays. Yeah, exactly. Two time series data set. Okay, exactly. If time series from the set are not equal size, NaN values are appended to the shorter ones, and the shape of the resulting array is NTS, which is the number of time series, I guess. That's the first dimension. The second dimension is the max SZ, so that's the largest size. So one that, yeah, if there's one with 70 years, then that's the second dimension is 70 years long, and D is the number of data points, basically. Yes. So for me, this would be the number of years. The number of countries, the number of years, and then the number of variables. Okay. Importing standard time. Okay, so this is like an example data set, and the shape is 1,000, so they have like 1,000, whatever that is, 128 time periods, and one data point. Okay. Be useful to rescale time series using tools from this. Okay. Oh yeah, we do need to do some scaling, so that's good. Yes, we need to do some scaling. Yes. Okay, so first of all, I think I'm going to go with GDP. So let me just put this here. I'm going to put some notes here. So select target variable. Okay. The answer is RGDP. PNA. Okay, fine. Question 2. It's not really questions. It's like goal 1, goal 2 is select the input features. Okay. Okay. So let's so let's do step 2 now. So at this point, we're gonna go and open this data set. I'm sure I've had this open before. Here? Yeah. Okay, so the reason I opened this is because here I'm just loading the data, and here I have some labels for the data as well. So it's still loading. I'll get some water. So I think something went wrong with the loading. Oh no, it just finished. Okay. So legend, please. Okay. Something is stuck here. Oh, okay. Maybe it's just my computer streaming and doing stuff. So yes, just resize this window here. We're going to think about what we're going to use here. So we're predicting our GDP NA, which is down here, national account based variables. It's the RGDP national account at constant 2017 national prices. So this is right. So this is kind of with not kind of ignoring exchange rates by taking inflation into account. That's why it's real GDP and not nominal GDP. But as opposed to these ones, which are purchasing power adjusted GDP values in US dollars. which is we don't care about, so we're not trying to predict those. But obviously the population will make a significant difference to the GP. This is not per person, this is total. So we're going to include for sure population. So we'll just write pop here. Okay. Then number of persons engaged, employment. Yeah, I think that makes sense. If I didn't edit it out, because I did, yeah, I think employment is one of the ones that dropped out because of my filtering method. I think the problem is that a lot of countries just don't have employment data. So I don't know how to deal with that. Okay. Oh, I see why my computer is running a bit slow. It's this is I reduced it. Usually I reduce it to 1080 HD when I'm recording something, but now it's on a higher resolution. So I don't know what I can do. Because I just have to be patient. Or I just don't use Google Sheets because that runs slow. I could just look at the data here before it's processed. So let me switch back here to the legend. Oh my god, now everything is... Can I still run this? Oh yes, thank you. But back to the legend here. I could also just load the legend in. I might do that because this is just painful now. Okay. So let's show this. Okay, I'm also gonna go, let's bring in the legend because we can. Just gonna call that legend. Okay, run that. Oh, oops, now that's fine. I'm gonna create another code block. df, another code block, legend. So yeah, well, probably what I want to do is count how many of these values for employment are actually empty. So let me do that. Which would be to do this, I think. Run that. And then show me that. So I have 3,200 missing values. I think that's not too bad because we have some 12,000 values in total. So it's about a quarter that's missing. Yeah, I think that's not too bad. I think because we have, that's only 800 more than these ones which are missing. So there's a lot of stuff missing. Yeah. Okay. I think I want to take a break here. Yeah, it's been 45 minutes. I'm going to take a break for 10-15 minutes and then I will continue. So I'm going to stop the stream and then restart it in 10 minutes or so.